From pasture to plate, the intricate journey of factory-made cheese. Cheese, creamy, sharp, nutty, tangy, or buttery, is far more than a staple on charcuterie boards or a topping on pizza. It is a living testament to human ingenuity, microbial collaboration, and centuries of culinary evolution. While its origins trace back over 7,000 years to nomadic herders storing milk in animal stomachs, today's cheese is often crafted in highly sophisticated factories that honor tradition while embracing precision, scalability, and food safety. But how does a simple white liquid become one of the world's most diverse and beloved foods? Let's follow the full, intricate journey, step by meticulous step, inside a modern cheese production facility. 1. Milk, the foundational ingredient. It all starts with fresh, high-quality milk delivered daily from trusted dairy farms. Depending on the cheese variety, this milk may come from cows, most common, goats, sheep, or even buffalo, each lending unique fat profiles, protein structures, and flavor nuances. Upon arrival, the milk is immediately tested in the factory's quality control lab. Parameters checked include temperature, must be chilled below 4 degrees Celsius, 39 degrees Fahrenheit, bacterial count to ensure freshness, antibiotic residues strictly prohibited, fat and protein content critical for yield and texture. Milk arriving in insulated tanker trucks may hold up to 30,000 liters, nearly 8,000 gallons. It's swiftly pumped into refrigerated storage silos where it awaits processing, typically within 24 to 48 hours to preserve quality. 2. Standardization and separation. Not all cheeses require the same milk composition. Before pasteurization, milk may undergo standardization, a process that adjusts fat and protein levels to match the recipe for a specific cheese. Whole milk, 3.5 to 4% fat, is used for cheeses like cheddar, Gouda, or brie. Skim or partially skimmed milk, 0.1 to 1% fat, is preferred for mozzarella, ricotta, or low-fat varieties. To skim the milk, it passes through a high-speed centrifugal separator. Spinning at over 10,000 RPM, this machine exploits density differences. Heavier skim milk moves outward, while lighter cream collects at the center and is siphoned off. That cream isn't wasted. It's sold or used on-site to make butter, ice cream, or yogurt. 3. Pasteurization. Safety meets purity. Next, the milk is gently pasteurized, a non-negotiable step in commercial production. While raw milk cheeses exist, under strict regulations, most factory cheeses use pasteurized milk for safety, consistency, and shelf life. The standard method is high-temperature, short-time pasteurization. Milk is heated to 72 degrees Celsius or 161 degrees Fahrenheit for 15 seconds. Then, rapidly cooled to 4 degrees Celsius or 39 degrees Fahrenheit. This kills pathogens like Salmonella, Listeria, and E. coli, while preserving essential proteins and minerals needed for proper curd formation. 4. Inoculation, awakening the microbial symphony. Now comes one of the most fascinating phases, adding starter cultures. These are freeze-dried or liquid blends of lactic acid bacteria, LAB, such as Lactococcus, Lactobacillus, or Streptococcus thermophilus, each selected for the target cheese. Mesophilic cultures thrive at 20 to 30 degrees Celsius, are used for cheddar, Gouda, or feta. Thermophilic cultures, 30 to 45 degrees Celsius, suit mozzarella, Swiss, or Parmesan. As the cultures ferment lactose, milk sugar, into lactic acid, the pH drops from about 6.7 to about 5.2. This acidification prepares the milk for coagulation, inhibits spoilage microbes, and begins developing flavor precursors that will blossom during aging. This ripening stage lasts 30 minutes to 2 hours, depending on the cheese. 5. Coagulation, the birth of curds. Once the ideal acidity is reached, rennet is added. Traditionally extracted from calf stomachs, most modern factories use microbial or fermentation-produced chymosin, a vegetarian-friendly, highly consistent enzyme. Rennet triggers enzymatic coagulation. It cleaves kappa-casein, a milk protein, causing casein micelles to clump into a 3D gel network, the curd. The remaining liquid is whey, rich in lactose, minerals, and whey proteins. After 30 to 60 minutes, the milk sets into a clean breaking gel like soft custard. A skilled cheesemaker tests readiness by inserting a clean knife at a 45-degree angle. If it lifts cleanly, it's time to cut. 6. Cutting, cooking, and stirring. Sculpting texture. The curd is sliced with stainless steel harps, arrays of wires, into uniform cubes. Large curds, approximately 1 centimeter, retain more moisture. Softer cheeses, for example, Havarti. Small curds, approximately 3 to 5 millimeters, release more whey. Firmer cheeses, such as Parmesan. Then comes cooking. The curd-whey mixture is slowly heated, often to 38 to 55 degrees Celsius, 100 to 131 degrees Fahrenheit, while gently stirred. This encourages further whey expulsion, syneresis, tightens the curd structure, and halts bacterial activity at the right moment. Temperature and duration are precisely controlled by programmable logic controllers, or PLCs, a blend of artisan judgment and digital precision. 7. Draining and molding, giving cheese its form. Once cooked, the whey is partially drained. The curds may undergo cheddaring, stacking and flipping slabs to expel whey, as in cheddar, or stretching, heated in hot water and pulled, as in mozzarella. Then, curds are scooped into perforated molds, stainless steel or food-grade plastic forms that define the cheese's final shape: wheels, blocks, cylinders, or even braids. Light pressing, for example for brie, preserves a delicate, open texture. Heavy pressing, for example for Gouda or cheddar, creates dense, sliceable wheels. Molds are often lined with food-safe cheesecloth or drainage mats to allow whey to escape without losing fine curds. 8. Salting. Flavor, preservation, and rind formation. Salt is never just a seasoning. It's a multifunctional powerhouse. Enhances flavor, controls microbial growth, slows acid development, and draws out surface moisture to form a protective rind. 2 primary methods are used. Dry salting, salt is rubbed directly onto the cheese surface, common for aged cheeses like Parmesan, or brine salting. Cheeses are submerged in a saturated saltwater solution, often 18 to 23% sodium chloride, for hours to days, used for mozzarella, feta, or Gouda. Brine tanks are temperature controlled, and cheeses are flipped regularly for even absorption. 9. Aging, affinage, where time works its magic. Now the cheese enters the maturation room, a climate-controlled sanctuary where temperature 8 to 15 degrees Celsius, 46 to 59 degrees Fahrenheit, humidity 80 to 95%, and airflow are fine-tuned for each variety. During aging, enzymes from milk, rennet, and bacteria break down proteins, proteolysis, and fats, lipolysis. This creates free amino acids, fatty acids, and volatile compounds, the building blocks of complex flavors like nuttiness, fruitiness, or umami. Surface molds, like Penicillium camemberti on brie, or internal eyes from Propionibacterium in Swiss, may develop. Aging can last days, fresh mozzarella, weeks, young Gouda, months, aged cheddar, or even 2 to 3 years, Parmigiano Reggiano. Cheeses are regularly turned, brushed, and monitored, some even washed in brine, beer, or wine to encourage unique rind ecosystems. 10. Packaging and distribution. Once matured, cheeses are vacuum sealed, waxed, or wrapped in breathable film depending on type and shelf life goals. Labels include batch numbers, aging dates, and origin, ensuring full traceability. From the factory, they're shipped in refrigerated trucks to supermarkets, restaurants, and export markets, often within the same week. Bonus: the second life of whey. Nothing is wasted. The whey, once considered waste, is now a high-value co-product. Sweet whey, from rennet coagulated cheeses, is used in whey protein isolate, sports nutrition, infant formula, or ricotta by reheating and acidifying. Acid whey, from cultured cheeses like yogurt or cottage cheese, is used in baking, animal feed, or biogas production. Innovatively, whey proteins are even being used to create edible films and biodegradable plastics. Conclusion: a symphony of science and soul. Modern cheese factories are not cold, automated assembly lines. They are temples of transformation, where microbiology, chemistry, engineering, and centuries of craft converge. Every wheel that leaves the facility carries within it the grass the cow grazed on, the culture selected by the cheesemaker, the rhythm of stirring, the patience of aging, and the joy of human taste. From humble milk to gourmet delight, cheese remains one of humanity's most elegant collaborations with nature.